Okay, first day of at-home learning. Here's our video. There'll be questions you'll need to answer as we go through it, so the screen will pause. Want you to do the work, type your answer into the boxes provided, and then that's how you get credit for watching the video today. We're working on logical arguments and line relationships. Today we're going to be talking about counterexamples and conditionals and conjectures, making statements based on some information we're given. Inductive reasoning, we're going to start with that. We're working toward our proofs. We're going to have to start reasoning some stuff out, so we're going to start with inductive reasoning. It's reasoning that uses a number of specific examples to arrive at a conclusion, and then assuming an observed pattern exists and will continue, we make a decision based on that inductive reasoning. So we're just going to be looking at patterns and things like that to try to see what's happening. Can I make a statement based on what I've discovered? An example, we're given these lists of movie times, 8:30, 9:45, 11, 12:15. We notice the time between each of these is an hour and 15 minutes. So our inductive reasoning is telling me that the movie is an hour and 15 minutes long. So if I had to guess when the next movie was, I'm just going to add an hour and 15 minutes to 12:15 and would get our time of 1:30. That's what we're going to be doing in this unit, the first part of this unit. Another example, or conjecture, sorry, we go to the conjecture. The conjecture is the statement we make at the end, where in that last example, we decided that the movie was going to be at 1:30 based on the inductive reasoning we used to find out that everything was an hour and 15 minutes. Here's another example where we're looking at a list of months. We have December, May, October, March, not in the order that we expect, but now we got to figure out what are they trying to tell us. So if we look at it and kind of count from December to May, the difference is 5 months. From May to October, again, it's 5 months. October to March, 5 months. Our inductive reasoning tells us that they're skipping every 5th month. So our next item that we're looking for after March, 5 months from March, is going to be August. So, like I said, every month is the 5th month of the previous, so our next month will be August. That's what you're going to be looking at, trying to do in some of the stuff that we're working on in the notes and for the homework. So here's some examples for you. Take a few minutes. The video is going to pause, like I said. Take a few minutes and figure out what we're looking for. We want to make the conjecture, and then what's our next item. Okay, so what we're looking at here, we see our statements. Our statement should look in our induction reasoning is we're going down by 6 every different number. So our next number should be 14, which is what you should have had for your answer. So the next number is going to be negative 14. The next example, I hope you didn't draw it out. We see that our triangle goes from a solid blue triangle to 3 blue triangles and a white triangle in the middle, to then looks like they're putting white triangles in the middle of all the shaded blue areas. So that's your inductive reasoning. It looks like every shaded triangle is split into 4 triangles with a white one in the middle. So then the next picture would be crazy number of small triangles. So all of that one there, if you just had the inductive reasoning, then I'm cool with that. I didn't need to see what the next actual thing was. Conjectures and counterexamples. So now we're looking at what a conjecture is. And conjectures are statements that may or may not be true. So going based on the information we have, that may be true, that may not be true. You may just be given a conjecture. You have to figure out if it's true. To be true, it must be proven. So it has to be true for every single iteration of a possible being. So it only takes one false example to disprove our conjecture. And that one example is the counterexample. It's the false statement that proves a conjecture. It can be a number, a drawing, or a statement. It doesn't have to be all 3 of them. It could be a number, it could be a drawing, it could be a statement. It's something that just proves what we're being told is not true. An example, a math example. If n is a real number, then n squared is greater than n. As long as n is greater than 1 in this example, that's true. 2 squared is 4, 4 is greater than 2. 3 squared is 9, 9 is greater than 3. The problem is when we have 1 is a real number, 1 squared is still 1, so that makes our conjecture false. So the whole statement's false just because 1's not greater than 1 when you square 1. Another example in the geometry world is we're told if JK equals KL, then K is the midpoint of JL. We learned that just in that last unit. The midpoint of a line segment makes the two sides of the line segment true. So if we kind of drew that in, we have our line segment here. That's J. Here's L. We have K in the middle. Congruent sides. That's what our conjecture is telling us. To prove it's not true, we just need one example to prove that it's not true, and that's our picture here, where we have JK and KL are congruent because of the red hash marks, but line segment JL doesn't even have K in the middle, so now K is not in the middle or the midpoint of JL, so our conjecture is false, and we can move on. We've proved it incorrect. Again, a couple more examples for you. I want you to come up with a counterexample for each statement to prove that it's negative, or to prove that it's not true. I guess not negative, but just prove it's not true. So again, take a few minutes, pause the video. The video will pause. You'll have to type in your answer in the box. Okay, so a real number, again, real numbers can be positive and negative. So anytime we have a negative real number, our statement's not going to be true because a negative of a negative, or the opposite of a negative, is a positive. So if n is a negative number, then negative n would be positive. In angles A and B, complementary angles, we know complementary angles add up to 90 degrees. They don't necessarily have to share a common side, because you could have two 45-degree angles that don't even touch that add up to 90 degrees, but they're not sharing any sides. Hope that makes sense. This is what we're trying to do for this unit. Next, we're looking at conditional statements. So a statement is a sentence that can be either true or false. The true or false part of it is what they call the truth value. Again, it's either true or false. Our example here, statements are usually represented by a P or a Q. So here's our example. A rectangle is a quadrilateral. That's a true statement. Rectangles are quadrilaterals. If we had a rectangle as a triangle, again, it's a statement because it's a sentence, but that's a false statement. So it doesn't have to be necessarily true or false. It's either or true or false. They don't always have to be true. The negation of a statement, that is just the opposite, or gives us the opposite truth value. So it has the opposite meaning as well as an opposite truth value. So again, they're represented by the squiggly line with a P or a squiggly with a Q. Again, we have not P, it's red, not P. So not P, a rectangle is not a quadrilateral. All the negations are going to have is not in them. They're always going to have not somewhere in the sentence. And again, that was a negative. It had a false statement. It was a false truth value. Two or more statements, we can join statements by and or. A conjunction, those are the statements, the compound statements using and. Our example here, we have two possible options. So a rectangle is a quadrilateral and a rectangle is convex. We combine those into our conjunction P and Q. A rectangle is a quadrilateral and a rectangle is convex. And then because both P and Q are true, the whole conjunction P and Q, which sometimes in math you're going to see notated this way with the little upside down mountain kind of thingy. That whole conjunction now is true because both P and Q are true. For the conjunction to be true, everything has to be true. We can't have one part true, one part false. So here's our example. We have three statements. A figure is a triangle. Statement P, the figure is a triangle. Statement Q, the figure has two congruent sides. And statement R, the figure has three acute angles. They're first asking us for P and R. The figure is a triangle and the figure has congruent angles, three acute angles. That's how we write the conjunction. So that's what we're looking at. Now we have to determine if that's true or not. The figure is a triangle. Obviously from the picture, it's a triangle. We can see that it's a triangle, but it's a right triangle. So because it's a right triangle, right angles aren't acute. The three acute angle part of this, our conjunction, is false. So that's going to make our whole conjunction false. The next conjunction they're asking about is P and not R. So now they want us to take, remember, the squiggly R is the not, the negation of it. So they want us to take statement Q and not statement R. So our conjunction now is the figure has two congruent sides, that's Q, and the figure does not have three acute angles. That's the not R part. We added the not. So you have not, that's the squiggly. Again, we've just proven that it doesn't have three acute angles, so that makes R not R true, but Q is also true because it has two congruent sides. So now our whole conjunction is true. The other side, examples for you, take a few minutes again, the video is going to pause, look at the picture, look at what they're asking you for, P and Q, and then not P and not R, write the conjunction, how the conjunction would look, and then tell me whether it's true or false. Okay, so we should have had that. You should have time to do that now. You have your answers entered. P and Q, the figure is a triangle, and the figure has two congruent sides. Again, we look at it. It's a triangle with two congruent sides. So P is true, Q is true, therefore the whole thing is true. Not P and not R. The figure is not a triangle, and the figure does not have three acute angles. Again, it's not going to be true. It's going to be a false conjunction because the figure is a triangle. So part P is false. So that makes the whole thing false. Does that make sense? Okay. Disjunctions. The disjunctions obviously are the statements that are connected with the or. So now, again, the disjunction, only one of the statements needs to be true. P is true, Q is false. The disjunction is true. Again, it's written now with the upside down, so the V rather than the mountain. Our example, January is a fall month. Q, January has only 30 days, and our January January 1st is the first day of the year. They're asking for Q or R. So our disjunction would be January has only 30 days, or January is the first day, January 1st is the first day of the year. January has more than 30 days, so that's false. But January 1st is the first day of the year, so because R is true, our whole disjunction is true. P or Q, again, we have January is a fall month, or January has only 30 days. So when we put that together as our disjunction, we have it, they're both false, so the whole disjunction now is false. Any questions on that? Does that make sense to everyone? Okay. Again, now it's your turn. A couple of examples. P, a diameter of a circle is twice the radius. Q, a rectangle has 4 equal sides. They want to know what P or Q is, and then not P or Q. Again, take a few minutes, type your answers in, and then the video will move on. Okay. The diameter of a circle is twice the radius, or the rectangle has 4 equal sides. Because P is true, the whole thing is true. The diameter of a circle is twice the radius. The second one, not P. A diameter of a circle is not twice the radius. A rectangle has 4 equal sides. Again, those are both false. We know that they're both false because we just proved that the diameter is twice the radius. So because they're both false or not true, the whole thing is false. Does that make sense to everyone? Everybody can kind of see that. They know where we're going, what we're working on, and how we're trying to get to where we need to be. Okay. So kind of a chart filling in everything. The negation is not P. The symbol is the squiggly P. And the statements P and not P have opposite truth values. If P is true, not P is false. If P is false, not P is true. Statement P and Q joined by the word and is a conjunction. We have the symbols P, cap Q, red P and Q. The conjunction is true only when both P and Q are true. And then statement P and Q joined by or is the disjunction. So then we have the P upside down cap Q or V. It's red P or Q. I will probably do a lot of it P or Q. the disjunction is true if only one of them is true. Or if both of them are true. Both of them are true, awesome, but it only has to have one of them true to be true. Conditional statements. A statement that can be written in if-then form. If it gets really cold, then it might snow. Conditional statement. Another example, if you are reading this page, then you are studying math. You're in the math video, you're in math class, so that is true. The phrase immediately following if is called the hypothesis, so that's the P part of it. The phrase immediately following then is the conclusion or the Q part of it. We're going to see that. There'll be a graphic, you're going to see what they look like. It's always going to kind of be written P then Q is kind of how it's read. That's how that's read, so they're telling you if P then Q. The conditional statement, we just did that. Conditional statement can be represented in symbols as P or Q. It's read P implies Q, or if P then Q. That's how you're reading it. They're only true when the hypothesis is true and the conclusions are true. A conditional statement is false if one counterexample exists, kind of just like the ones we were talking about before. The hypothesis of a conditional is not met. This is where it gets a little tricky. When the hypothesis of a conditional is not met, the truth of the conditional cannot be determined. And when the truth can't be determined, it's just assumed to be true. So it's not false. We don't know if it's true or not, so we can't prove that it's false. So we're just going to say it's true. The logic thing, just go with it. Sometimes they're not written in if-then form, and we're going to kind of need to change them. So if we look at our statement here, our statement is points will be deducted from any paper turned in after Wednesday's deadline. We kind of need to rewrite that in if-then form to kind of start working with our conditionals to do a better job with what we're going to need to do. So to rewrite that, you're going to rewrite it, if a paper is turned in after Wednesday's deadline, then points will be deducted. I know it doesn't make sense, but the conclusion part of it comes first. Usually, in a lot of the sentences like this, the conclusion part's at the beginning of the sentence. Excuse me. Whoops, went too far. No, that's good, sorry. So then we have what we call related conditionals. These are created by changing the hypothesis and the conclusion, both position and negating them. So we'll see them as we go forward. There are three types: the converse, the inverse, and the contrapositive. You're going to need to know what these are. You're going to need to intuitively understand what they are. The converse is created by just flipping the hypothesis and the conclusion. The inverse is created by replacing the hypothesis and the conclusions with their negations. So just making them all not statements. If not that, then not this. The contrapositive is created by replacing, again, we're going to replace them with the negated conclusion, but we're flipping everything. So we can see in the chart with what the symbols kind of look like and the arrows, the conditional is if P then Q. The converse is if Q then P. We've flipped it. The inverse is not P then not Q. We have examples out at the end to see what they all look like. And the contrapositive is not Q then not P. So we started with if two angles are vertical angles, then they are congruent, which we learned last unit that that's true. If two angles are congruent, then they are vertical angles. Again, just flipped everything, still has to be true. The conditional and the converse are always going to be the same truth value. The inverse, if two angles are not vertical angles, then they are not congruent. Not necessarily true, so that's going to be a false statement because we can come up with examples where that's not true. Other than the contrapositive, if two angles are not congruent, then they are not vertical angles. We have that statement there. So we'll see some examples kind of showing what they are. The contrapositive is kind of the most confusing of these. Again, we'll work through it and have it sorted out. A conditional statement and the contrapositive are both either true or false. So if the conditional is true, the contrapositive is going to be true. And then the converse and the inverse are either both true or false. So if the converse is true, the inverse will be true. If the converse is false, the inverse will be false. Does that make sense? Okay, our example. Lions are cats that can roar. That's what we're told. That's our given. Our conditional statement. If an animal is a lion, then it is a cat that can roar. We've put it into our if-then statement. That's true. We're told lions are cats that can roar. So if an animal is a lion, it's a cat that can roar from our true statement. The converse. If an animal is a cat that can roar, then it is a lion. While that is true, it's not always true, because a counterexample is a tiger is a cat that can roar, but it's not a lion. So this is not a true statement. So now, based on what we just learned, our inverse is also not going to be true. If an animal is not a lion, then it's not a cat that can roar. Again, a tiger is not a lion, but it can roar, so that makes our statement false. And then, like I said, a counterexample. A tiger is not a lion, but it is a cat that can roar. The contrapositive. If an animal is not a cat that can roar, then it is not a lion. So, if anybody has a house cat, it can't roar, it's not a lion, it's a true statement. Only lions are cats that can roar. So if it's not a cat that can roar, it's not going to be a lion. Make sense? Okay. It's your turn for this. We have the, I gave you the conditional. I want you to write the converse, the inverse, and the contrapositives, and then tell me whether they're true or not. And here's what you should have had. If two angles are congruent, then they have the same measure, which we know is true. If two angles are the same measure, then they're congruent. It's true. Inverse is if two angles do not have the same measure, then they are not congruent. Again, that's true. And the contrapositives, if two angles are not congruent, then they do not have the same measure. Again, all true. So all those statements were true. Biconditional statements. This is a long definition. These are statements when the conjunction, the conditional statement and its converse. So it's the conjunction of the conditional and its converse. They're typically joined by the words if and only if. I'm sure you've heard that before. If and only if. Like I tell my daughter, she can go out to dinner with her friends if and only if her homework's done. So both the conditional statement and the converse must be true for the biconditional to be true. Our example, angle O has a measure between 90 and 180 degrees. Angle O is an obtuse angle. The biconditional, angle O has a measure between 90 and 180 degrees if and only if angle O is obtuse. Another example, two angles whose measures add up to 90 degrees are complementary. So our biconditional statement, angles are complementary if and only if their measures add to 90 degrees. Take a few minutes to figure out what the biconditional is going to be for this statement. Okay, we should have taken the time. Our statement here is an angle is an acute angle if and only if it measures between 0 and 90 degrees. Like we learned, it can't be 0 because it's no angle, so it has to be between 0 and 90. 1 to 89.99999. Okay, so that's the end of our video. Check out Google Classroom for the rest of your homework and enjoy the rest of your day.